Okay, let's factor some quadratic expressions. This is kata, I don't know how to say it. Their worksheet for this. There is a backside that I am not going to do. It is more advanced. This is just going to be kind of the general basis. If you want to do the more advanced version, I'm sure you can find videos out there. And I'll flip it over so that if you want to try it on your own, you can. I'm just not going to go through it. When you factor, originally you are looking at like ax squared plus bx plus c, and a, b, and c are numbers. You want two numbers that are going to add to your middle that also multiply to your last. And this is the foundation and the process we're going to follow for most of these. So if we look at number 1, we want two numbers that are going to add to -7 and multiply to -18. What I do is I make this factor tree with -18, and I think of all the things I can multiply to get to -18. So I have a -1 and a +18. Well, I can switch that and have a +1 and a -18. So I have 6 choices. If I look at these 6 choices, again, these all multiply to give me -18. There's only going to be one that adds to give me -7. So I like the +2 and the -9. Because if I were to write this out, so I have x plus 2 and x minus 9. If I multiply these out, I would get -9x plus 2x, which would give me -7x. +2 times the -9 is a -18. And that's it for factoring. That's done. Over here, the same idea where we have a -14. So one of our numbers is going to be negative and the other is going to be positive. We only have 4 options on this one. We want to know where we're going to add to a -5. Well, looking at this, again, it's going to be a 2. It's going to be a +2 and a -7. So I'm going to have x minus 7 and x plus 2. And the order doesn't matter. Here I did the 2 first and then the 9. Here I switched it. Multiplication doesn't matter. 2 times 3 is the same as 3 times 2, you know, so it's fine either way. For 3, something I want to point out, if this is c value, which is your constant, the number that doesn't have a variable, is positive and your b is negative, automatically you can ignore the place where they're both positives. So a +1 times a +8 does give me a +8, but there is no way to add 2 positives to give me a negative. So then that eliminates 2 options and I'm only left with 2. Well, to get to -9, I have to have a -1 and a -8. So I'm going to have x minus 1 and x minus 8. For 4, I have a positive c and a negative b. So again, we can ignore all the positive options. That eliminates half of them. And because this is a positive, both numbers either have to be negative or have to be positive. Because this is a negative, that's why we're crossing out those 3 where they're all positive. -63 and -1 definitely would not add to -16. -3 and -21 will get you kind of decently somewhat close, but -7 and -9 will give you exactly what you want. Okay. I'm going to look at 5, 7, and 9 instead of going back and forth all the time. So I'm going to do these 3 and then I'll go to 6, 8, and 10. The unique thing about these is they have an a value that is no longer 1. So with 1, 2, 3, and 4 that we've already done, our a value from our ax squared plus bx plus c was 1. But when it's more than 1 and you're doing this add, one of the numbers is actually going to be multiplied by 7. Because when you have your boxes, like if you use the area model or when you're just multiplying it out, to get this 7x squared, you have to have 7 times 1 to get this 7x squared, and 7x will be multiplied by whatever's over here. And that's why I set it up like this, so you can see that one numbers of these options is going to get multiplied by 7. Adding your other number will give you -31. So we have 6 choices, and you can guess and check, especially when it's set up in this format. I like that. It keeps the same format. You can just plug in different numbers. Right off the bat, I don't think it's going to be 20 and 1, so I'm going to not do that. If I look at 2 and 10, I know I don't want to multiply 7 by 10, but maybe 7 times 2, and then I'm subtracting 10. So I can keep that in mind. Looking at 4 and 5, that seems to be a little more close. And what I'm doing right now is I'm walking you through the process I would do if I didn't know the answer. 7 times 4 is 28. Right off the bat, that's pretty close. 7 times 5 is 35. That's also close. So that's a good place to start. Because my answer is negative, I'm going to guess that my other number is going to be, or my bigger number is going to be negative. Excuse me. So I'm going to go ahead and try 5 and 4. And I think I'm going to put 5 here and 4 here. The next question is which one's going to be negative. I'm going to make my bigger number negative. I can double check this. 7 times negative 5 is negative 35 plus 4. That is negative 31, so that does work. The tricky part here is what you put in this that parenthesis is actually going to go right here. So I'm going to have 7x plus 4 times x minus 5. That's going to happen because if I put it right here, it doesn't get multiplied by that 7. So if I were to put 5 here, I would be doing 5 times x and 4 times negative 7, which gets me close, but that doesn't get me my negative 31 that I want. So that's another good way to think of it. I struggle with it too, and that's why I circle or draw arrows or something so I know which one goes where. I can do that same process, and 7's a really good practice one because it has the 7 as well. So you're following the same process where one of them is going to, you're multiplying to 7. One of them is going to get multiplied by 7. So I know I'm going to have 7x something and x something, and I just got to figure out what goes where. I want to add to negative 45. But again, 28 and 1 probably not going to get me there. 7 times 14 is going to be too big. So I like the 4 and the 7. If you don't know how to make these factor trees, I just start with 1 and I work my way down. Like 1 times 28, 2 times 14. Oh, nothing times 3 would give me 28. 4 times 7. Nothing times 5, nothing times 6. When I get to 7, this is going to be the same pair. All right, so back to my what adds to make negative 45. I like 7 and 4. 7 times 4 is only 28. So I'm going to put the 7 in here and the 4 over here. Because this is a negative, I think my 7 is going to be negative. 7 times negative 7 is negative 49. Plus 4 is indeed negative 45. So again, what I put right here is actually going to go over here. And so I'm going to put my x minus 7, and then I had my plus 4 right here. All right. For number 9, we're following the same idea but with a 5, and we're only adding to a negative 1, so a lot smaller than what we've been doing. 5 times 18 is going to be too big. 2 and 9, maybe. 3 and 6 would give me 15 or 30, probably not, so I'm going to go back to this 2 and 9. It's only a negative 1. Well, 5 times 2 is 10, and 10 and 9 are only 1 apart. And again, you only have 6 options, and technically 12 if you switch the order. So if you can get this set up right here, you can guess and check, and you can use process of elimination. You can be like, oh, that's too close, too far, and go from there to kind of change what you are doing. But I think I'm going to end up multiplying 5 times 2 and adding my 9. It's a negative 1, so I think my bigger number, like total, because 5 times 2 is bigger than 9. And yeah, that does work. So again, I'm going to have this negative 2 down here, and that plus 9 in with the 5 because that's not getting multiplied. Okay, I like 6 because there's 2 different ways you can do it. First, when I only see 2 terms, or if I see really big terms like we're going to see in number 10, I try to see what they both have in common. And what I mean both is the 2 individual terms that we have. They both have a k. So what I can do is I can divide them both by k and pull this k out in front. 7k squared divided by k is just 7k. 9k divided by k is 9. So I put the k out in front because I can't just get rid of it, and then I have what I had after I divided. And that's it. the other way to do it, if you want to follow the add and multiply that we've been doing, it is a little more difficult when you're multiplying to 0 because it's just going to be 0 in some term, and you want to add to 9. Well, that's nice because if you're adding a 0 to get 9, you know your other number has to be 9. So you could have, just like earlier, we know we're going to have a 7k and a k. We know we want to multiply to 0 and add to 9. So I'm going to put my 9 here and my 0 here, because if I put my 9 here, I'd have 63 instead of 0. I'm sorry, 63 instead of 9. That's my bad. I can double check this. 7k times 0 is 0 plus 9k is 9k. 9 times 0 is 0. I'm good. This is equivalent to this. You could also, if you really want, put your k in the back because order of operations does, or order of multiplication doesn't matter. I took a 5-minute nap on the floor before this video, so I'm a little out of it and I apologize for that. Again, this is probably how I would write it, but these two are equivalent and they're not wrong. Looking at 8. Same idea of what we've been doing where you're splitting it up, what multiplies to the number in front of your b squared or your x squared or whatever you're dealing with. The nice thing about 2 is even though it's an even number, it's only 2 and 1. And we can follow the same idea of what we've been doing. 1 and 21 would probably get you to too big of a number, so I'm going to look at 3 and 7. And 2 times 3 is only 6. And I want 17, so I'm going to put my 7 here and my 3 here. Now it's a positive 17. So none of them are negative because they are either both negative or they're both positive, and I want a positive answer. 2 times 7 is 14 plus 3 is 17. So I have my 2x plus 3 and then my x plus 7 again because this 7 has to go opposite so I can multiply them just like I did here to get that 17. You can also do the quadratic formula, and I'm still deciding if I want to come back to the quadratic formula eventually. I like the quadratic formula more when it is harder to factor. And what I mean by that is when my a value is more than 1, because this is a bit, okay? But I do want to show you this first. When you have all of these numbers, what they all have in common, well, they all have at least an n squared because this has 2 n's, this has 3, this has 4. So I can pull this n squared out here. They're also all even numbers, so I could pull a 2 out. If I did the 2 first, they would still be even numbers, so I can pull out another 2. And because I've pulled out 2 2's, I have pulled out 4 total. And the same idea of what I did earlier, 28n to the 4th divided by 4n squared gives me 7n squared. Because I had 4 n's, I got rid of 2, I have 2. 28 divided by 4 is 7. I repeated the process with 16 divided by 4 is 4. Had 3 n's, got rid of 2, left with 1. Had 2 n's, got rid of 2 n's, none. 80 divided by 4 is 20. Once I get this broken down, then I can do the same idea of factoring where I'm adding and multiplying. When you write your factor, because I pulled this out, it will be like 4n squared, 7n something, and something. So just because you factored this out, don't lose it. Now this actually is a really good opportunity to do the quadratic formula, and I think I'm going to take this opportunity. So before I do, I'm going to find somewhere I have a little more space, and it's negative b plus or minus the square root of b squared minus 4ac all over 2a. If you want to like learn that and memorize it, if you're not allowed to use notes, or you just want it stuck in your head, there is a song, and it's to the tune of Pop Goes the Weasel, and every time I mention it, it is stuck in my head forever. This b, a, and c that you see are from your ax squared plus bx plus c, and you're just plugging in the numbers. So looking at number 10, I'm going to be going back and forth here a little bit. My a is 7, my b is 4, and my c is negative 20. So all I did is a, b, c. And I can plug these numbers into my quadratic formula. So I have a negative, my b is 4. If it was a negative, include that. Plus or minus the square root of 4 squared. And I don't need to in this situation, but I'm going to, because if that's a negative number, you are going to want parentheses around it. This 4 is always here, same with this 2. Do not get rid of these numbers, they stay. You are only replacing a, b, and c. So I have 4 times a times c all over 2 times my a, which is 7. Okay. Couple things I want to note about this. This is technically going to be 2 answers because I'm going to have one answer where I have plus the square root of 16 plus, sorry, I'm doing this in my head, give me a second, 560 over 14. Let me double check that. Yeah, I did it right. Okay. I really don't want to mess it up for y'all. And then my other answer is going to be when I subtract that same thing. If you have like nice calculators, you should just be able to put in this and get the answer and this. As a teacher, we want to see at least this, so we know how you put it into the calculator and we know if something got messed up in the calculator or if something got messed up in your calculations or whatever. From here, you can simplify it and it should just pop out your answers, kind of how we did when we did our factor tree. So 576, so I have negative 4, and I'm going to go back to this format just because I don't want to write it every single time. So 576 over 14. You cannot, I cannot stress this enough, you cannot divide this 576 by 14. You have to find the square root first, simplify it if possible, add or subtract, and then divide by 14. So I don't have a calculator on me right now. I'm going to go ahead and find my calculator on my smartwatch, and we will do it that way. I lied. No, we won't. I'm going to go get a calculator, and you go ahead and try to input this to get your values. Okay, I'm back. This is going to simplify to negative 4 plus or minus 24 over 14. Okay. I don't have a lot of space on this paper, so I'm currently trying to figure out how I want to do this. Again, we have 2 answers here. I'm just going to keep going down. Sorry, I know this is gross and not well organized. This is one answer, and this is your other answer. Negative 4 plus 24 gives you 20 over 14. That is going to be a fraction. Negative 4 minus 24 gives you negative 28 over 14. That's going to be a whole number. So this is negative 2. And then 20 over 14 is 10 over 7. And there's a couple different ways we can do this. It is not a nice fraction. So I'm going to simplify it to 10 over 7. Okay. We know that one of these is going to get multiplied by 7. We know our other one is just negative 2. This negative 2 is going to go right here. And my 10 is going to go right there. And actually, what I forgot is that when you do this quadratic formula, these are the answers, not the factors. So I'm actually going to switch my signs here. and make this the negative 1. And now we can double check this. If I plug in 2 here and negative 10 here, I get 14 minus 10 equals 4, which is correct. The reason for that is because if I set 7n minus 10 equal to 0 and I solve like we have done in several of the other lessons, you get the positive 10 sevenths, but that's a negative 10 right there. Same if you set your n plus 2 equal to 0 and you subtract 2 from both sides, you get that negative 2 that we came up with earlier. Okay, that does get confusing, and obviously you just watched me struggle with it too. So keep that in mind. There is nothing wrong double checking your answers in multiple different formats. The quadratic formula is really nice to use, especially in these situations, because this one wasn't terrible, but some of the other ones on the back aren't lovely. They're harder. And if you don't want to do this process, if you don't want to guess and check, if you'd much rather do the quadratic formula, talk to your teacher, see what they want you to do if they have a preference. Again, I prefer factoring when it's something like this or where there is no a value greater than 1, but you can still do the quadratic formula with those. Okay. I'm just going to flip over and kind of show you what the back would look like, and I did already set up some of these problems so you have a start. I am just not going to discuss it with you. Okay, so I did already do the factor trees for everything. I will just briefly kind of show you what everything looks like here, and then you can pause it at any point and be like, yeah, that's the one I want to do. I did not do the critical thinking questions. That's actually where I wrote the quadratic formula I was contemplating doing. When I say it can be broken up, that means you could have like 9r and r, or you could have 3r and 3r. And that's where the quadratic formula might come in handy, because otherwise you're going to have to be like, oh, I could have 9 times something plus something equals negative 5. I could have 3 and 3 equals negative 5, and then you're going to have to run through multiple options. And that's what I've got. Just a reminder of if a is greater than 1, you do have to multiply. That's the rule for factoring. Here's the quadratic formula again based on this. One more time, do not change your 4 and your 2 here. Make sure you use parentheses around the numbers you're plugging in, especially the b's, and then this represents 2 answers. So I hope this helps you with factoring. Keep practicing and doing great.